Okay, so let's get started. So yeah, thank you so much for having me today to talk with you all about some of the wind products that you would receive from NHC for all tropical cyclones that we issue advisories for. So here's a list of the different things that we're going to go over today. So again, we're talking about wind-related products, and so that would include things like the tropical weather outlook, the forecast advisory. We'll talk a little bit about the error cone, the wind speed probabilities, time of arrival graphics, and then watches and warnings. So let's get right into it. First, let's start out with the tropical weather outlook. So the tropical weather outlook is our product that we use to really essentially be an assessment of any tropical cyclone activity that's ongoing or expected to happen over the next 7 days. So the way this is organized is that it's a text product that lists out any active tropical cyclones in the particular basin of interest, and then any other systems that we're monitoring for development and whatever the chances of development are for that particular location. So here's an example of a system that in a particular year we may have been monitoring over the Bay of Campeche. You can see that kind of designator there at the top tells where the system is located. So in this case, it was located over the Bay of Campeche. And then all the text below that regional designator then is a description of the system and then a description of its prospects for development, again, over the next 7 days, and any other information that we think is important for users to be aware of. After that paragraph of information, then you'll see essentially the formation chances for the next 48 hours or 2 days, and then again through the next 7 days. So in this particular case, we said that this system had a medium or 50% chance of developing over the next 48 hours, and then a 60% chance of developing over the next 7 days. By looking at those particular percentages, you could see that we expect the most of the chance of development would be in that first 48-hour period because it's encompassing 50 of the 60% in that particular case. So that's kind of the general framework of how the text product works. As I mentioned, if there are any active tropical cyclones, it would also be listed there as well. As I mentioned, in that text, it'll be giving you information about the potential of development, where it might be headed over the next several days. And then with that text product, there is a corresponding graphical product. This is what the graphical tropical weather outlook would look like. Essentially, it's just mirroring the text product, but it's actually putting markers on the map to show where the systems are located, if they exist yet. And then, as you'll see here, the 7-day graphic showing you the genesis area or the potential genesis area where those systems might actually form. So actually what you're looking at here, this is the 2-day graphical outlook, where the systems are now and what their chance of development is over the next 2 days or 48 hours. We do this categorically. So essentially we're highlighting these X's or disturbances in low, medium, or high categories and giving them the probabilities. So a low chance of development would be less than 40%, a medium chance of development would be 40 to 60%, and then a high chance of development would be anything greater than 60%. One of the things that's new this year, which isn't actually depicted on this particular graphic, but we have introduced a gray X. And you can see there in the legend, a gray X essentially means that it's a system we're watching, but we don't expect development. It's essentially a 0% chance of development in that case. Most of the time, we would use the gray X for systems where the probabilities have come down to 0 and we're about ready to drop it from the outlook entirely. Or there could be some cases where we think a system is going to be a heavy rain producer, but we don't think it has a chance of actually becoming a tropical cyclone. In those cases, we could use the gray X just to highlight the system, to mention the heavy rainfall threat, but again, that we don't actually expect development. So starting this year, essentially, you're going to see 4 potential colors: gray for no development, and then yellow, orange, and red, which highlight the different chances of development in those categories. Here's the corresponding 7-day outlook. Again, it looks a little bit different. It doesn't have the satellite background because we're looking out to 7 days, and so obviously the satellite image itself becomes obsolete. So essentially what it's doing is showing where the systems are located now. If they exist, there will be an X, and then the genesis areas where the storm could form if it forms at all. You can see in this case, the red system there obviously has a high chance of developing over the next 7 days in a larger area because it could move within that area over the next 7 days and potentially develop. Some of the other systems on this particular example have lower chances of development, probably within the short range, the 48-hour period, and so they're much smaller areas of where we think development could occur. One of the important things about the outlook is that it's not a track forecast. So while you look at these ellipses or shapes, you might think that's the general trend of where the storm may move, and that is true, but it shouldn't really be looked at as a specific track forecast. It's really just the area where we think formation could occur. And the reason for that is that it's possible that the actual track of the storm could extend well beyond the boundaries of the genesis area if we're talking about a 7-day forecast. But maybe we think genesis is going to occur, say, within the first 4 days. So it's not going to encompass the entire 7-day track of the system itself. It's only depicting where we think formation could occur, if it does in fact occur at all. And I should mention that the 7-day outlook is what is the default on hurricanes.gov. So if you go to our website, that's the graphic you're going to see as the default. There are links then to get to the 2-day graphic if you'd like to look at that. And then again, this graphic is showing you the chance that the system forms within that area within the next 7 days. Okay, so we've talked about the outlook. Now let's talk about once we actually have a tropical cyclone or a post-tropical cyclone or potential tropical cyclone. Essentially the systems where we're actually issuing advisories for the storm. Tropical cyclones come in several different flavors. So they can be categorized based on wind speed. So tropical cyclones can include tropical depressions, tropical storms, hurricanes. We don't have it listed here, but it can also include subtropical depressions and storms. We can write advisories on post-tropical cyclones, which essentially means that it was a system that was a tropical cyclone. It is no longer a tropical cyclone, but it might still remain a wind or surge threat to land. Some of the examples that we've seen in the past is Hurricane Sandy became a post-tropical cyclone technically just before it made landfall in New Jersey. And our policy has changed that allows us to continue writing advisories on these systems until those wind and surge threats have diminished. Hermine from several years back was another example where we continued advisories after the system had transitioned to a post-tropical cyclone because there was still a wind and surge threat in that case. So that's kind of the back end threat of tropical cyclones that are transitioning. We can also write advisories on the front end for some systems, and these are what we call potential tropical cyclones. These are systems that have not yet become tropical cyclones, but we think they will over the next couple of days. And we also think that there's a threat of tropical storm force winds or significant surge on land within the next 3 days or 72 hours. That was actually a policy that was extended from 48 hours last year in 2025. We did not use it in the United States last year, but we did use it once off the Pacific coast of Mexico with major Hurricane Eric, which hit near the Acapulco area. We were able to get advisories initiated on that system 72 hours before those impacts did reach land, and it hadn't even formed yet. It wasn't actually a tropical cyclone. So in order for us to write these advisories, we have to have those criteria met, is that we think it's going to become a tropical cyclone and there is a threat of tropical storm force winds or surge on land, again, within that 72-hour period. If you were to take a look at the Hurricane Center website right now, you'll notice that we just started advisories on potential tropical cyclone 1, which is near the coast of Texas, because again, it's not a tropical cyclone right now, but we expect that it could become one over the next day or so as it's moving near the coast. One of the things that this product allows us to do is actually issue watches and warnings for these systems, even though it does not yet have a name, it does not yet have a number for as a depression, has not become a tropical cyclone. So we start the advisories, but can still issue those watches and warnings. Okay, moving on, I want to talk a little bit about how we communicate wind risk. And one of the things that we often see is that people will use what's called a deterministic forecast or a single scenario forecast to assess their risk of getting winds from a hurricane. So essentially that's like the Hurricane Center making the forecast for where the storm is going to move, how strong it's going to get, how big it's going to get, but there's no forecast uncertainty accounted for in that particular forecast. That would be a track and radii forecast out to 5 days, which we do provide. The hurricane radii go out 3 days. But the key here is that a deterministic forecast assumes a perfect forecast. It assumes that what we put out from the Hurricane Center is not going to change. It assumes that the center of the storm is going to move along the forecast points in the cone. It assumes that the strength is not going to change, and so forth. And we know that that's just not the case. Forecasts change, storms evolve, and so we can't really rely on a single scenario forecast. So for that reason, we also have wind speed probability products, because what these products do is they take the official forecast, but then they apply the uncertainty in that forecast of track of the intensity and the size, and actually produces probabilities, the chance of getting tropical storm force winds at particular locations, or strong tropical storm, or hurricane force winds. These products can also provide the time of arrival of when those tropical storm force winds might start at different locations. And then a feature that's only in HURREVAC, not actually on our website, there's also time of departure information. When do we expect or think that those tropical storm force winds could depart or end at particular locations? So the point here is that when we're talking about preparedness and evacuation decision making, we have to account for the uncertainty in the forecast when making those decisions, because if we rely solely on the deterministic forecast, we can really get ourselves in trouble if the storm speeds up and gets there sooner than we were expecting, or if the storm gets bigger than we were expecting. If we don't account for those possibilities, then the decisions we make could be essentially inaccurate or put people's lives at stake because they weren't told to evacuate when accounting for those possibilities. So we'll go back to the basics of our forecasts. With the forecast that we make, one of the products that we do put out is called our forecast advisory. This is what it looks like. It's not very pretty. It's very structured in the way that it's put on paper. But really what we put out this product for is mostly for different types of computer programs to read the information and then plot that information in a way that's more easily digestible. But to show you what it looks like, it gives the direction of motion of the storm, the pressure, the winds. It gives these radii in quadrants, and I'll show you that an example here in a second. It does it both at the current time and then within the forecast for the next 5 days. So again, here's the current radii. We're looking at how far out from the center do those winds extend in each quadrant of the storm. And then we also do that in the forecast sense, not just what's going on now, but in this case, what's it gonna look like in the next 12 hours in that forecast. And this is what the radii look like, or what we actually mean when we talk about radii. It's very difficult for us to analyze or even forecast exactly what the two-dimensional structure of a storm looks like or is going to look like. So the way we do that is by essentially decomposing it into quadrants. So what we're doing is essentially telling you how far out from the center do we think winds of different thresholds extend, or what's the maximum extent in that particular threshold. And this is what it might look like if you were plotting it. So the purple there is the tropical storm, or 34 knots. The yellow is the 50-knot winds, and then the green would be the hurricane force winds. And it's kind of structured in this quadrant sense. Again, it's the largest distance from the center in each quadrant that those winds would extend. Now, the thing we have to make clear is that this doesn't mean that those winds are occurring everywhere in those shaded areas. Because it's just a maximum extent, you could have lulls and gaps within that quadrant where the winds of that threshold aren't actually occurring. Again, because we can't really assess or forecast the complete two-dimensional structure of a storm. So it's a little bit of an oversimplification. It can also be an overestimate of the radii, especially storms that are near land, because you're going to have stronger winds over water than you might have over land. So if a quadrant intersects or combines, moves over both land and water, we're going to draw to where those winds extend over water. Even if the quadrant extends over land, it doesn't necessarily mean that the land areas are going to get exactly those levels of wind as well. So it can be a little bit of an overestimate of exactly how big a storm is, especially when those storms are near land. And that's just some kind of where we are in the state of the science and how well we're able to actually assess the structure of a storm. Now we talk about the size forecasts going out through the next 5 days, the wind radii forecasts. What you see here is what is actually provided by NHC. So we will provide the 34-knot radii, which in HURREVAC, if you look, it's shaded in blue. We will provide that for the entire 5-day forecast. We do that for the same way with the 50-knot winds, which are depicted in yellow. We provide that for the entire 5-day forecast. And then when it comes to the hurricane force radii, where we think the hurricane force winds would extend, we essentially do that through the next 3 days or 72 hours. And that would be highlighted in red in HURREVAC. We do not provide that, at days 4 and 5, largely because the skill at forecasting that particular variable is not very good at those time ranges. So right now, based on the science, we're able to provide at least a semi-accurate prediction of how far out those hurricane force winds will extend from the center, up to 72 hours away in the forecast, but not at days 4 and 5. So just to show you, kind of compare the deterministic single scenario versus the probabilistic, in this case, what we would call the worst case scenario. On the left, this is an example from Hurricane Milton 2 years ago when it was over the Southwest Gulf. We were expecting it to move to the northeast toward the Florida Peninsula. And you can see that just based off the deterministic forecast, essentially the area in blue is where the tropical storm force winds were forecast. The yellow is the strong tropical storms. And then in red is the hurricane force winds. The first thing that you'll notice is that even though we had a hurricane forecast to make landfall in Florida, the hurricane radii in red don't extend along the track past this point over the Gulf. And again, that's because we're not providing that particular forecast out beyond 3 days. So even though a forecast for a hurricane is being made, the radii aren't going to extend beyond 3 days. So that's one of the limitations of the deterministic forecast. However, by applying the wind speed probabilities and taking what we would call a reasonable worst case scenario, you can see now that we're plotting areas that have the risk of getting those wind thresholds that are taking into account the forecast uncertainty. So now you can see that in red, that's shaded all the way up to the coast of Florida. There's even some red on the eastern side of Florida because there is a chance of hurricane force winds everywhere within that red shaded area. It's accounting for the track uncertainties of what if the storm shifts north or south. It's also accounting for the size uncertainties. What if the storm was to grow more in size than we're actually forecasting? So you can see that the right side image is much more applicable to understanding your risk of winds from a storm and not relying solely on the single scenario deterministic forecast there on the left. The other thing is looking at timing. So we could do the same thing with Milton, where we had a forecast. We wanted to know when were the winds going to arrive, let's say in Sarasota, Florida. And we could step through showing the wind radii moving across the Gulf and when do they hit Sarasota versus do we do it in a probabilistic sense, where we take all the different scenarios that could happen with the storm, and based on all those scenarios, what are the probabilities showing for when those winds could occur? And one of the things that you'll be seeing later today is the wind timing reports and scenarios that are generated by HURREVAC, where it will provide you essentially the deterministic timing, which assumes a perfect forecast of when those tropical storm force or strong tropical storm force winds could start, versus applying some essentially probabilistic methods to that, where we have our earliest reasonable timing start of those winds, or our most likely timing start of those winds. So you can kind of see a range there when you're comparing the different types of arrival. As I mentioned earlier, this type of information is also available for the departure time. So you can have a deterministic perfect forecast for a departure and also apply the probabilities to look at a most likely and a latest reasonable time. So just as an example, if I'm looking at when will the winds start in Sarasota, I'll see based on a perfect forecast, deterministic, is 3 a.m. on Wednesday the 9th, which is essentially 88 hours away. But if I apply the probabilities, you'll see that the most likely time of those winds starting is actually 1 a.m. on Wednesday, or 86 hours away. And then there's this earliest reasonable time of 2 p.m. on Tuesday, which is 75 miles away. So if the storm were to speed up or grow in size, then those winds could start earlier than what's in the actual deterministic forecast. And this is actually more useful for decision making by applying those uncertainties to the forecast. When you go to our website, hurricanes.gov, for all active cyclones, we have essentially what we call a storm box that has a lot of the forecast products. The text products are linked there, and you see in some of the yellow shading. And then we have all the different graphical products that we provide as well. I want to talk a little bit about the error cone because I know that many people have seen this cone. It's probably our most popular product of all the products that we issue. I think one of the things that you should know is that what this cone shows you is the probable track of the center of the tropical cyclone. It is not an impact cone. So don't look at it as in I'm inside the cone or outside the cone, I'm safe or I'm not safe. It's only telling you where the center of the storm may travel over the next 5 days. The way that we create this cone is essentially by looking at all of our forecast errors over the past 5 years, and we draw circles around each forecast point such that it contains the center of the storm 67% of the time, or 2/3 of the time. And again, we draw those circles and then we connect a cone or draw a line around the circles that creates the cone over the 5-day period. So it's not telling you anything about the hazards of the storm, only where the center of the storm may move over the next 5 days. Based on these statistics, then we would also expect that the center would move outside the cone 1/3 of the time, or 33% of the time. As I mentioned, it only displays information about the track uncertainty, and impacts from the storm can occur well outside the area of the cone itself. You can even see in this example here, there's that kind of orange shading there, which is the area of tropical storm force winds right now. You can see that that area extends beyond the boundaries of the cone. So just imagine if you're stepping that storm along, even if it was to get bigger in size, those tropical storm force winds likely would extend beyond the boundaries of the cone itself. So impacts can extend beyond the cone. The center of the storm itself can move outside of the cone. So do not look at the cone as an impacts graphic. It's only where the center of the storm may move over the next 5 days. One of the things that we've introduced for this hurricane season, and we actually did test this out over the past 2 years, is that with the cone, we have always plotted the watches and warnings that are in effect for coastal areas. But starting this year, we're going to do that for all inland areas as well. So in this particular example from Hurricane Helene from 2 years ago, you can see the forecast there with the cone moving north into the Florida Panhandle and then into the southeast United States. What we did is we plotted all of the tropical storm, hurricane warnings, tropical storm watches that were in effect for that particular forecast. And you can clearly see that the wind risk extends beyond the boundaries of the cone. We got wind risk across the whole state of Florida, up into Georgia, to the east, into the Carolinas. That again, areas that are outside the cone because the center of the storm is expected to go further to the west, but because of the size of the storm, its motion, there is a wind risk well outside of it as well. So this is new for this year. It's operational. The other change you'll notice is that the 5-day cone has changed a little bit. If you look at previous years, we actually had a different type of shading at days 4 and 5. It was kind of some stippled shading. We have changed that, so the entire 5-day cone now is white shading. And so one of the reasons we've done that is we are talking about extending the forecast out to day 6 and 7. So we wanted to make this change now in preparation for that possible change in coming years so that there's no differentiation or confusion between the different time periods. So as I mentioned that, we don't want people to focus just on that skinny black line or the line that would be connecting those points. Perfect example of that is Hurricane Charlie. This is kind of our poster child for not focusing on that line. If you remember with Charlie in 2004, the initial forecast had the track pointed toward the Tampa Bay area, and the storm actually took a slight deviation. Again, it wasn't a hard right turn. It was, as was often said after the storm, it was a slight angle to the right, and just that slight angle ended up changing exactly where the hurricane force winds occurred over the state of Florida. So if you were using a deterministic forecast, a perfect forecast, yes, you would have thought that Tampa Bay was the only place at risk of getting those hurricane force winds, when in fact, because of that slight shift, areas farther south got the winds, up near Orlando even got those winds. So it was a significant impact for areas because of that slight shift to the east. The thing about the track of Charlie, however, is if you look at this diagram, is that the center of the storm technically stayed within the cone itself. The orange dots there are where the storm ended up moving. So again, it wasn't a hard right turn, but it was just enough of a right turn that it kept it in the cone, but exactly where those impacts, the major impacts happened, was very significant to the people in those areas. So this is why we have to account for the uncertainty in a forecast, because it's not going to be perfect. We know things are going to deviate, and we want to be able to communicate that in a way that's useful for people. So one of the ways that we do that is by calculating wind speed probabilities. And in particular, the way that we do that is by taking the official forecast that's put out by the Hurricane Center and essentially creating a family of storms. And it's 1,000 members of that family that are deviated around the official forecast. So we'll assume that some of the tracks are to the right, some are to the left of the official forecast. We'll assume that some are faster, some are slower. We'll assume that some get stronger or weaker than the official forecast, and then we'll also deviate the size of the storm as well. So all the variables that we could be wrong on, essentially, we're deviating them in a sensible way that accounts for the uncertainty in the forecast. So for the Charlie case, we have this family of storms, 1,000 of them, showing that the realistic possibilities of where the storm could have actually moved over the next 5 days. Based on running those 1,000 members of this family, we can then calculate that based on all of those family members, how many of them are producing different wind speeds at different locations on the coast. And if we looked at the hurricane force wind speeds, you'll notice that for Charlie, there was essentially a 30% chance of hurricane force winds in Tampa. There was also a 30% chance of hurricane force winds in Port Charlotte. And this is when the storm was still south of Cuba. So you can see that by using the probabilities, we're able to accurately assess the risk of wind along a stretch of coastline that is accounting for the uncertainties of where the storm may actually move and how big it might be as well. So the risk in Port Charlotte at that stage was just as great as it was in Tampa. And that's where using that essentially that perfect scenario could get you in trouble if you were focused on the deterministic forecast. One of the things that we produce when it comes to probabilities is a text product that will provide you the chance of the different thresholds of wind. I don't have a lot of time to go into this in depth. In fact, I'm not going to even try because it's a little complicated, and HURREVAC can do this for you a lot more simply. But just to tell you that it does provide location-specific probabilities at the different wind thresholds. It also presents onset timing or probabilities based on the numbers or how high those numbers are at each forecast time there in the columns. There's also a cumulative probability. Maybe the easiest way to read this product is just look for that number all the way on the right there in the last column. That gives you the total chance of that wind threshold over the next 5-day period. So for example, for Tallahassee, you can see that there's an 81% chance of tropical storm force winds, a 48% chance of strong tropical storm, and then a 24% chance of hurricane force winds. So again, it's kind of a complicated product to learn how to use, and HURREVAC can, in general, do this a lot easier for you to give you your probabilities as well. Also, if you don't like the text product, we do provide the graphical products that will provide these thresholds as well. So here's the chance of tropical storm force winds. Here's the chance of strong tropical storm force. And then here's the chance of hurricane force winds. And again, these are location-specific probabilities. So it tells you the chance of getting those winds at a specific location, not for an entire region or an entire state. We also have products for time of arrival, and those come in two forms. We have our earliest reasonable arrival, which is, if you think back to the family of storms, it essentially tells you when do the first 10% of those members bring winds to a location. That was what we call our earliest reasonable. So in this case, you can see those winds could start in areas of the Big Bend of Florida as early as 8 p.m. on Tuesday. We also provide a most likely scenario, which is when essentially half the members bring winds to a location. It's kind of the middle of the distribution. In that case, you can see that the winds are most likely to start in the Big Bend of Florida around 8 a.m. on Wednesday. So there's about a 12-hour difference between those particular product types. Then I want to touch on watches and warnings. So watches and warnings have very specific definitions that we use to determine what areas should be put under a watch or a warning, and then also to help you understand when those hazards for wind may start in an area. So first off, for the tropical storm watches and warnings, a tropical storm watch means that tropical storm conditions are possible somewhere within the watch area, generally within the next 48 hours or 2 days. Then, once we get closer in time or the risk increases, then we get to what we call a tropical storm warning. And that's when tropical storm conditions are expected somewhere within the warning area, generally within 36 hours, so a day and a half. So if you have problems remembering what a watch is, what a warning is, just remember that a watch is possible, generally within 48 hours, and a warning means that they are expected, generally within 36 hours. Possible within 48 hours, expected within 36 hours. And then it's equivalent for a hurricane watch or warning. It's just that in this case, the probability of hurricane conditions is sufficient that we have to put up hurricane watches and warnings. A hurricane watch means that hurricane conditions are possible somewhere within the watch area, generally within 48 hours. And a hurricane warning then means that hurricane conditions are expected somewhere within the warning area, generally within 36 hours. One of the important pieces of the puzzle to remember for a hurricane watch or warning is that it's tied to when tropical storm force winds would start in an area. The tropical storm force winds have to start before the hurricane force winds because winds obviously gradually increase over time. And people need to have most of their preparations done once those tropical storm force winds begin. So we tie all of our watches and warnings to the arrival time of tropical storm force winds, and that does include the hurricane watch and warning as well. Again, keep in your mind the watch means possible within 48 hours, and the warning means expected within 36 hours. So again, a lot of products that we're talking about here, and we do have a pretty set cycle for when products are issued. And I want to go over that now here as we start to wrap up. So this is our advisory timeline. This is the schedule of updates. When we have no watches or warnings in effect, an NHC advisory is put out every 6 hours for an active tropical cyclone. So you can think about it, if we're thinking Eastern time, it would be 5 a.m., 11 a.m., 5 p.m., 11 p.m., so forth. If we're talking about Central time, it would be 4 a.m., 10 a.m., 4 p.m., 10 p.m., and so forth. And then if we're talking about Hawaiian time, then it would be 6 hours prior to Eastern or 6 hours after Eastern. So it's actually 11 p.m., 5 a.m., 11 a.m., 5 p.m. Hawaiian time. So every 6 hours, you're getting a new forecast. In each of those forecast packages, as we call them, you're getting a public advisory, a forecast discussion, the wind speed probabilities, forecast cone, any type of storm surge updates, but specifically talking about wind. This is kind of the set cadence for when you're going to see those new products every 6 hours on those particular times. This is also when you could potentially see possible watch warning changes. So if we're not issuing any watches or warnings, but then there comes a time when we need to issue watches and warnings, it would occur generally on these 5 and 11, 5 and 11 timelines. Now, once we actually have watches and warnings in effect, you'll still get the forecasts every 6 hours, but in between, you'll now get a new public advisory in those 3-hour increments. So now you're going to get a public advisory at 8 a.m., 2 p.m., 8 p.m., and then 2 a.m. In between the actual full advisories. Now, you're not getting a new forecast track. The forecast itself is not changing. You're merely getting an update to the information about the forecast based on what the forecaster is seeing. It is possible that you could see watch warning changes on these intermediate public advisories. We can make changes now on those public advisories at those intermediate times. Now, as the storm gets closer to land, we can get even finer resolution in how often information is sent. You're still going to get the 6-hour forecasts. You're still going to get the intermediate advisories in those 3-hour increments. But now, once a system is essentially within radar range near the coast, we are tracking it by radar. We can issue what's called a tropical cyclone update every hour so that there's never a gap. Every hour, you're getting new information, whether it's a TCU or update or a public advisory or a new forecast. You're getting information from us every hour when those storms are very close to land. So that's a real quick rundown. I will mention that with this whole kind of cadence of products, what we don't have listed here is that we can also issue what's called a special advisory. So if something significant has changed the forecast, if the storm has strengthened rapidly, if the track has shifted significantly from what was just issued, we can also issue a special advisory to update everything at an off time. So it may not be 5:11, 5:11. It could be at an off time because we want to get that information out to you as quickly as possible. So also be aware that that's kind of an unscheduled update, that you could see these special advisories at any time if we think something significant has changed with the storm. So that's kind of a quick overview of all the wind type products that we issue. There's my contact information. If you have any questions that you think about later, feel free to reach out to me, robert.berg@noaa.gov. Otherwise, I'll turn it back over to John to see if there's any time for questions right now before we move on to some of the show and tell.
Yeah, thank you so much, Robbie. And I will actually check in with my colleague, Franny, to see if there are any of those questions that we can take right now.
Thanks, John. Hey, Robbie. There's been some discussion in the questions about the transition between tropical to post-tropical. Can you talk a little bit about how you do that handoff and what kind of decisions you have for issuing, say, some of the information after it goes to post-tropical?
Yeah, sure. So usually what happens when we talk about post-tropical, there's two forms of post-tropical. There's a system that becomes what we call extratropical, which is like, think about like a wintertime storm where it's a bigger type storm. In the winter, it causes snow. Obviously, we don't get that usually in the summer, but it has more fronts associated with it. It's not purely tropical. So we can have that type of transition. We can also have systems that are essentially dying. They're becoming remnant lows, where they're losing all their thunderstorm activity. They're just essentially on a decaying mode. Mostly for the ones that are becoming extratropical cyclones that have fronts associated with them, the key here is that if we've been issuing forecasts, we've had watches or warnings in effect, and that system becomes extratropical, we don't want to just drop all the services that we've been providing for the past several days. We don't want to drop the watches and warnings if there are still hazards in wind and storm surge that storm is producing. So we are now able in the Weather Service to continue those advisories as a post-tropical cyclone until those particular hazards had died off. One of the impetuses for this was Sandy. At that time, we were not able to issue post-tropical cyclone advisories. So once the system technically became post-tropical, we had to cease advisories. And obviously that's not great, because then you don't have the watches and warnings anymore. Watches and warnings might change type. And we just wanted to clean that up a little bit. So essentially it's working with the other offices in the Weather Service. If we see that transition may have occurred, then we would coordinate with them to continue those advisories until those hazards have come down to a point where we don't need the watches and warnings in effect anymore.
Thanks, Robbie. That's really thorough. Really appreciate it. I think that's mostly it, Robbie and John, from questions on this side.
All right. Well, thank you, Franny, and our Q&A support for taking those on. And thank you, Robbie, for spending all this time with us today, especially with active weather out there. We really appreciate you providing that background understanding of how these products are made, because now that we transition into the HURREVAC demo, we're going to show everybody where you can find them and how you can apply them. So always great to have you with us, Robbie.
Yep,
and we'll hear more. Thanks, Robbie. And we'll hear more from the National Hurricane Center and other NOAA agencies tomorrow as we go into detail on the storm surge and inland flooding tools. Before we go into our demonstration, I do want to do a get to know you poll question. And this first one is where you tell us about your area of responsibility. We know we have a lot of HURREVAC users all over the country. In fact, throughout the Atlantic and Pacific basins, and in a lot of different roles and different types of agencies. And so some of you may be focused on a single location, like a particular facility or campus, or are you responsible for a single locality, a city, town, county, parish? Would you describe your area of responsibility as more regional, like a larger area made up of multiple counties or cities scattered around? Or are you working on the state or national level? And so there's 4 options for you there, and I'm going to give it about 30 more seconds for you all to make your selections, and then we'll take a look. And this is always interesting to take a look at. It does change a little bit every time we ask it in different years, but it really underscores why HURREVAC has so much functionality to it. we have users, 13% of you, single site. We have 28% of you concerned with a single locality, 22% working on the regional level, 37% either state or national. So there are tools and layers in HURREVAC that are tailored in some cases to users who are working more on the county level, or in other cases, there are reports for wind timing that may be of much more interest and use to those of you who have statewide or national responsibilities. And so as we take a look at what our goals are for today, we are going to cover a lot of ground, but it's important to keep in mind, not every single one of you may be looking at every single one of these tools on a daily basis. We're presenting all of this to you so you can get an understanding of it, and then you can figure out, as you get to know the program, what's going to work best for your operations and what's going to work best for your workflow. So to kind of maybe head off a little bit of information overload, just know that we are going through pretty much a comprehensive tour of the offerings today. And we'll start by plotting on the map these National Hurricane Center wind products that we saw in Robbie's presentation. We're going to make sure we understand the differences between probabilistic and deterministic products as you see them in HURREVAC. Then we're going to make a wind report for one particular locality and understand what that means and what goes into it. We're also going to create a report with wind information for many different localities and areas. And we're also going to use our points of interest to customize the wind information. We introduced points of interest a little bit yesterday. We're going to talk about it some more today. Now, first, before I go into my HURREVAC workspace, if you had been logged into the program between about 10:20 and 11:20 this morning Eastern Time, you would have seen a notification in the top right corner of your workspace that looks like this. This was the special message from the National Hurricane Center, where they put on their website, hurricanes.gov, a red banner that says NHC will initiate advisories on potential tropical cyclone 1 over southern Texas at 10 a.m. Central Time, or 11 Eastern Time. One of the useful things that HURREVAC is designed to do is it captures that information from the NHC website and reproduces it inside HURREVAC. So if you happen to be working on something else, you would have seen that little bulletin in the top right corner letting you know to check back later in the hour for taking a look at the new advisories coming out on this new system. And this is routinely one of the things that we see. And there are other reasons why we may have a notification in the top right corner. Karen mentioned some of them yesterday in that demo, but Robbie mentioned in the presentation earlier that the tropical cyclone updates, those bulletins that are issued on an hourly basis once a storm is very close to land in the US with watches and warnings in effect, those products, the TCU or tropical cyclone update, are also brought into HURREVAC in the top right corner as a notification. So I'm going to move back into my HURREVAC workspace, and some of this will be a little bit of review from yesterday, but you might already notice that things look different from what we were seeing yesterday. What is turned on by default changes now that we have an active system we are tracking in the Atlantic. We do still have the tropical weather outlook turned on by default, but that region of probability that we were seeing yesterday, that did indeed get to the point where it required advisories in the form of the potential tropical cyclone. As Robbie mentioned, this is not yet, as of the time of this broadcast, if you happen to be watching at a later date, this is June 16th, but as of this moment, it does not meet the criteria of being a tropical storm or tropical depression, but it may become one and bring those impacts. And there's a desire for forecast products that the users can respond to. And so this allows this storm to be plotted and tracked in HURREVAC, and of course in other places too. So the tropical weather outlook, sometimes you will see we are in a transitional state while the new advisories are coming out, the very first one, and there will still be a blob or shaded region on the TWO along with the track of that new system that is connected to that outlook area. There are times when we're in a really high impact situation and there's one major hurricane bearing down on the US, and nothing really else going on, and we believe that the vast majority of our users are interested in tracking that active storm. We may turn the tropical weather outlook off by default, just so that as you log into the program, your screen has as much information as possible that is just about that current threat. And the TWO is a fantastic situational awareness tool for us, but right now I'm more interested in this potential tropical cyclone. So I'm going to click into my toolbox or in the X in the top right corner of that small window to turn off the tropical weather outlook. So this is what HURREVAC looks like when we have an active storm in the Atlantic. When you log in, it will automatically plot the track of an active storm in the Atlantic basin. In fact, it's the only storm active in the world at this time, but in this active storms tab at top left, you would see a list of all the active storms in the world. In this case, we just have one, potential tropical cyclone 1. Another thing I'll point out as I do my demonstration for you today, the mouse pointer may be a little bit hard to follow, especially if you're watching on a smaller screen. So I'm going to highlight areas with a small circle feature that you'll see in the middle of the screen right now. And I'll use that to try to draw your attention to the places that I'm clicking. So we have the track of this active storm turned on. Really, this is not the focus of our instruction today. Of course, for the latest information on the system, you can refer to those products from the NHC, but the majority of our demonstration will be with an archived storm from a couple of years ago. But this way, you now see what changes in the HURREVAC interface when we are dealing with an active system. The other thing to point out about the notifications too is, as you saw in Karen's demonstration yesterday, there is the passive notification that was the Welcome to Webinar Week that will be up through the remainder of the week. But that is different in nature from the one that I showed earlier that expired within an hour because it's set to do so, because within that 1 hour, the advisory will be coming out and it'll no longer be needed. So we try to tailor the length of those to how long they're relevant to you. While we're on this live data, I just want to point out there is, since we are on the topic on the theme of wind today, that there is one layer in the conditions tab that pertains to current wind conditions. And in the top left corner of the workspace in the conditions tab, third from the bottom is this folder called wind. And there's two options here, wind speed and wind gusts. And this is an estimate of gusts and speeds across the United States with some coverage in the nearby ocean waters over the past hour. This is not direct observations. This is just a nationwide mosaic. And this particular layer doesn't project out into the future or look back into the past. So just know when you go to log in and look at this at a later time, this will look different. Also, if you're going back to look at an archived storm from 2 years ago or even just 2 days ago, this layer is not going to match an archived storm. You can only use this layer with something that's happening right now. We're going to spend a lot more time in the conditions tab tomorrow because this, as you can see, contains a lot of our forecast rain and excessive rainfall layers. But the wind gusts and the wind speeds have a legend at the bottom, and those colors correspond to the values on the map. So not particularly strong in that area where the potential tropical cyclone is at this time. To turn off any layer in the conditions tab, it's as simple as clicking the radio button again next to that tool. So we're done looking at potential tropical cyclone 1. So I'm going to uncheck that storm in the active storms tab. You see that now my workspace is kind of blank. It's removed the legend at the bottom and the storm status bar at the top. Those only show up if you have a storm checked on in the storms tab in the top left corner. In the example we will be using again today is Hurricane Milton from 2024. And so the fastest way to get to it is to type that name in the search bar. And in this case, there's only one Milton that exists in the archive. When HURREVAC loads a storm, it always goes to the most recent advisory because it wants to show you the latest information. And that's really helpful with an active storm. When we're looking at something that's an archive storm and we want to go through it chronologically, we have to go back to an earlier advisory. And there's a couple of ways to do that. You saw yesterday, you can click on the advisory label in the storm status bar at the top, and then you get this list that scrolls back to the beginning of time, or you can use your left and right keyboard arrows as a shortcut. So I'm going to choose advisory 8. And while we look at this list, I'll point out, as Robbie mentioned about the advisories, there are intermediate advisories showing up here, and those have an A at the end of them. And that means that at that time, there was a watch or warning in effect somewhere related to this storm. So advisory 5A, 6A, 7A, those updates came 3 hours after advisories 5, 6, and 7. But our main updates to the track and the forecast products come at those 5, 6, 7, 8, 9, those main advisories. So here we are, Hurricane Milton Advisory 8. And now a quick word about time and time zones. We know we have attendees here, not just in the Eastern time zone like I am, but in the Central time and watching from other parts of the world too. So HURREVAC is designed to know what your computer's system clock is in, and it will show that data converted to the time zone that's relevant to you. So at this time, if I'm in the Eastern time zone, I'm seeing 5 a.m. Monday, October 7th. If you're watching this from Louisiana, you are seeing 4 a.m. on your HURREVAC workspace. It's the same forecast information, just translated differently. As we mentioned yesterday, if you need to, you can convert it to a custom time zone in HURREVAC so that you can make graphics that support other regions. But we're going to be looking at a lot of times today, and I just want to make sure you're aware that this is how the program behaves, and that you will see different results if you're in a different time zone, but that is by design. You also probably see that my labels and my track depiction could look a little bit different from yours. My labels, I like having the motion of the storm and its forward speed turned on by default, so that I can see as this forecast landfall is happening, that we have a category 3 moving to the northeast at about 14 miles per hour. Remember that the track and swath options are where you can go to choose what is contained in the text next to these track labels. And so maybe I'm going to turn the forward direction and speed off for the rest of the day today, and click Save these preferences for future sessions. So the next time I log into the program, I will not see the forward direction and speed. And some of you may also be seeing 2 tracks along your HURREVAC map. One of the track that the storm Milton ended up taking, and another with a dotted line showing what the forecast was as of advisory 8. So if you want your screen to look like mine and make it look as if we were in HURREVAC on this morning of Monday, October 7th, what you would do is you would go into track and swath options, and the very first checkbox at the top called actual track ahead, you would uncheck that. And then that would mean you would only be seeing one track line on your screen. We'll come back into track and swath options a couple more times in the course of this demonstration. And we're going to do a little more setup for our demo for the rest of this hour that we have with you. And one of those steps is I'm going to set a base location, and I'm going to choose Pinellas County, Florida. And that is the county that has St. Petersburg. So as I zoom in, I right click around St. Petersburg and click Set Base Location. And as I do so, User Preferences pops up to remind me the statistics about that area. And it also has a link to the local National Weather Service office where I can quickly access the local office products. And the little flag shortcut reminds me where I just clicked. I won't see it the next time I log into HURREVAC, but know that that base location is still stored in your user profile until you change it again. So if you're following this demonstration with me, but you're in another state, it's as easy as just changing your base location back once we're done with this webinar. So that's part of what we want to do today. I also want to add my state and county boundaries for some reference for those of us who aren't familiar with Florida. So let's go to the top left corner, and the resources tab is the third one. And then the very first checkbox is our state and county boundaries. So they're a little easier to see the outlines of the counties as well as the names of them. Before we look at the wind forecast map layers, I'm going to do a couple more things to set the stage for creating wind reports later. And one of them is making some points of interest. We saw a little bit of this yesterday. I'm going to create some more today, some new ones in different areas. And first off, I'll make one somewhat near my base location. In fact, in the same county, I will right click around Clearwater. And the very fastest way to make a point of interest, just by using the map is to use the second option in the context menu called Create Point of Interest. And I can call it anything I want and give it any kind of type designation that may be useful to my operations. In this case, I'll just go with the name of the town. I'm also going to come up here into Pensacola and right click and create a point of interest there. And once again here around Cedar Key. And moving farther down the coast, we're going to go into Cape Coral, right click and create a point there. You don't necessarily have to do this if you're following along with my demonstration, but hopefully showing these later on, it will all come together if you're still trying to understand what points of interest can do for you. And coming down here into the Keys, I will make one at Key West. If I wanted to be more specific about how I was placing my points of interest, which is definitely maybe the case when we're talking about storm surge data, because it's very, very high resolution, as we'll see tomorrow, we may want to be more precise when we make our points if we're using them to analyze storm surge. And in that case, you would want to use the geocode location tool to help look up particular addresses, or just zoom in closer on the map if you know where you're going based on the streets. But to see my list of points and to temporarily turn them off from display, I'm going to use this tool halfway down the right side toolbar that looks like a map marker and click Points of Interest. And just check in the header and uncheck, and that will unselect all my points. They're still there in my user profile. I'm just not seeing the dot on the map. And I'll close out of that. We're going to come back to them later on. So remember to catch us up. We're looking at Hurricane Milton from 2024. I'm on advisory number 8, which is 5 a.m. on Monday, October 7th. And at that time, we had category 2 hurricane here with a forecast track pointed at the Florida Peninsula. And so what do we know about the current winds and the possibility of where the winds are going in the future? Well, let's start with our storm tool at the very top. So the storm tools are all of the colorful tools located to the left of the tracking map. The very first one is called Forecast Wind Field. Often we call it the wind rings for short because it takes on a concentric look. And this is what's drawn out based on that text advisory issued by the NHC that Robbie was showing us, where we were looking in each quadrant of the storm, what was the farthest extent of our wind thresholds. And here's a reminder about our color theme in HURREVAC. The tropical storm sustained 39-mile-per-hour winds are shown in blue. Yellow is for strong tropical storm of 58 miles per hour. Hurricane force winds in red at 74 miles per hour. And that theme carries through to a lot of different layers and a lot of different reports, with one exception that we will talk about. And this, again, is an estimate, and it can be especially so over land, but this is a useful look at how far those winds could be reaching out from the storm. Is it a small storm? Is it a large storm? Is it going to be expanding in size as it moves towards land? There's a lot of things, as we'll think about as we get toward Thursday's demonstrations, that can affect your timeline for how long you have before impacts begin. And one of the things that can compress your timeline isn't just a shift in the track, but if the storm is projected to expand in size, or if it's trending larger and larger as time goes forward and advisories come out, that can eat away at the number of hours you have before that hazard arrives. So knowing how big the wind field is pretty important. And so this is the advisory time of 5 a.m. Monday, October 7th. Another way of thinking about our time controls on the top is animating out into the future. We saw a demonstration from Karen about this yesterday. I'm going to show you again. To animate along the forecast hour, this depiction of the wind field, we can click on this menu in the top that says +0 hour and come down here to a later selection like 45 hours out past the advisory time. This takes us up to 2 a.m. on Wednesday, October 9th. And I can also control this with an hourly look by using my up-down keyboard arrows. And so this is just interpolating 1 hourly steps between these forecast points, moving this deterministic projection of the wind field forward in time. At a certain point, we will see the hurricane winds go away right there. And that's what Robbie mentioned, that the radius of hurricane force winds is forecast out to 3 days, or here 69 hours. And beyond that, we still have information about the size of the tropical storm force, a strong tropical storm force wind field, out through the rest of the 5-day period. It is also interesting to note, since we did cover potential tropical cyclones and had a question about extratropical cyclones, is that the color theming is the same for the wind hazard, regardless of how it's designated. So if it is forecast to become post-tropical cyclone, you will still see the wind field shown in those colors based on what the wind hazard is expected to be. And the same goes actually for potential tropical cyclone. We can have cases where it may be forecast to have some winds above the tropical storm threshold, even though it's not even forecast to be a tropical storm. And you may still see a blue square on the map indicating that wind strength at that point. So it's important to pay attention to the text advisories, especially the forecast discussion, to really understand the nuances of this. But that is the color scheme in HURREVAC. And one way of looking at this deterministic forecast is taking this wind field and animating it forward. I'm going to reset to the 0 hour using the time control at the top. And what about if we just wanted to see in a single glance all of the areas that may be affected by the wind forecast along this deterministic forecast? And that's where we get down into our next storm tool called the wind swath. And we're looking here, and there's 3 options: deterministic, probabilistic, and past actual. And the deterministic takes all of those hourly steps over the next 5 days and stitches it together into one depiction. And we have a red swath indicating that if this deterministic forecast, this one scenario, plays out the way it is projected to, these are the areas that may be exposed to hurricane force wind, and so on for the tropical storm force wind in the blue. Now, this is just one scenario. And so the second option down, called forecast probabilistic, gets to what Robbie was talking about with that 10% threshold. So similar colors, but now this is saying anywhere colored in blue has at least a 10% chance of reaching the wind speeds of tropical storm force. And that's what the legend says down here. And so anywhere in the red has at least a 10% chance of experiencing hurricane force winds over the next 5 days. And notice that this probabilistic swath takes up a larger area than the deterministic swath. And you'll also see where I have a little bit of a clash between the wind field layer and the wind swath layer. And so there's some things I can do in track and swath options to customize the look of those layers to make them a little easier to see at the same time. And the lower section of the track and swath options window is where I can control whether the wind field is depicted with fill or with a solid line or a dashed out line. And so maybe I'll keep the wind field with a filled style and come and change my wind swath to a solid line. And how you customize this and display it is really up to you, but know that HURREVAC gives you those options. And I'll keep things moving along by closing out of track and swath options and moving to the past actual wind swath. Notice I can only turn on one swath at a time. I'm going to go ahead and turn off my forecast wind field too. And this is a backwards look, stitching together all of the previous advisory points and taking those wind extents and trying to approximate where those conditions existed in the past. But if this is the only thing we're looking at, we're still missing quite a bit of information, so we've got to keep going through our storm tools. A quick word about the potential track area or error cone. We stepped through a lot of that important information in Robbie's presentation, but as it pertains to HURREVAC, it is our third icon from the top in the storm tools. And those of you who have used the program in years past, we will note a change for this year. There was previously an option in the potential track area called
fringe winds.
Fringe winds. Thank you, Franny. That has retired as of this year. That was a legacy for many, many years in the HURREVAC program. But in recent years, a whole lot of other products have come out from the NHC that speak to all manner of scenarios and uncertainty as it pertains to wind forecasting. And so that fringe winds depiction with the cone has been retired as of this year, in case we're wondering where that went. Moving on down from the cone, which is not telling us anything about the wind hazard, just the potential of where the center of the storm could be, we're moving into our probabilistic layers. And I'm going to start with the graphical wind probabilities, which is the fourth storm tool from the top. And there's three options here: tropical storm, strong tropical storm, and hurricane. And I can only look at one at a time. And this is the same information you would be seeing on the NHC website, but in this case, you can interact with it. And you may have situations too where you have a certain storm and a certain forecast where you go to turn on hurricane and you don't see anything at all because the probabilities are so low. In this case, we do see those probabilities showing up, and the cutoff is 5%, as you see in the legend at the bottom. So this is a composite of the next 5 days. For any particular point, what is the chance of experiencing hurricane force winds in this case? Or going back to this first option, tropical storm force winds. Another interesting thing to briefly note about this particular product, this is the only storm tool that actually shows other storms too. All of our storm tools are designed to be particular to the storm that you have turned on and is showing up in the legend. But as storm paths can overlap, you will see that this is a composite product for the entire Northern Hemisphere. So it's not an error if you are seeing other storm paths on the graphical wind probabilities layer. But if you want to investigate anything about those storms, you would have to turn that storm on and have that track displaying. But moving on, this is one way of understanding our probability of tropical storm force winds at a point. The other way of looking at it is the location-based wind probabilities, which is the tool right below that. It's a little triad of blue, yellow, red squares. And when we're really zoomed out, this doesn't show a lot of detail. We have to zoom into the regional or local level for these squares to be placed on the map in the location of those cities. And you see there's a selection, and mostly most major cities or metro areas are shown in this. And so if we are in or near one of these areas and want a quick glance of those numbers, this is a quick way to grab that information. So for Tampa area, 81% chance of tropical storm force winds over the next 5 days. That's what that 81 means in the blue square. And in the red square, that 30 means a 30% chance of hurricane winds over the next 5 days. And this is also derived from the text advisory that Robbie mentioned. And HURREVAC just displays this for you in a way that is easier to find on the map. So this, like everything we've seen so far, this updates every 6 hours when we get a new forecast track. So when we're at an intermediate advisory, like we go to 8A, well, actually in this case, the watches had stopped briefly, but you see I go to 10 here, advisory 10, 45% chance of hurricane force winds. So our trend has gone up in the Tampa area as of this time. We see advisory 10 come out 3 hours later. It's still showing 45% chance. That's because these probabilities and the other layers we've seen so far don't change at intermediate advisories, just at those 6 hour intervals. So something to be aware of when you're timing how you go into HURREVAC to check the latest information. Sticking with the probabilistic theme, we're going to keep working our way down the storm tools. We're going to turn off the location-based wind probabilities and turn on the tropical storm force wind time of arrival graphic. And there's the two options in here. There's the most likely arrival and the earliest reasonable arrival. The tooltip, if I hold it over the list, tells me what that means. Less than 50% chance of earlier onset for most likely. That's the statistical midpoint there. And then the earliest reasonable is the less than 10% chance of earlier onset. And in either case, when I go to turn this on, I have these lines with labels along them. And so the very first thing I'm going to do to help us understand this is turn off the track labels. So those labels along the track of the storm pointing to those squares, that is for where the center of the storm is going to be at that given time. The labels on the line we're seeing here referred to when the winds would be arriving. And storm being larger than a point means that those winds would be arriving before the center of the storm arrives. So to clean up this map a little bit, I've gone back into track and swath options and gone to the labels section in the middle and just unchecked that entire heading. And so now it's a little bit easier to read. Notice that this also covers the same area that we saw with the graphical wind probabilities. So think of this as anywhere that has a 5% chance of tropical storm force winds also has some information about the wind timing. And you may actually like layering these two together to tell your story. And if you're ever in a situation where the layers turn on in HURREVAC in the order that you turn them on. So if you saw that these were out of order, where the label was at the bottom and the color was on top of it, and you wanted to switch that around, remember you can go into the quick layers options. This is the storm tool that's third from the bottom. And this is where you can control the opacity of that probability data. And you could also move it below those lines and just adjust it to where it looks good for your purposes. And so that's an adjustment you can make to the data on the HURREVAC map. Turning off our graphical wind probabilities and focusing in on these times again. Here we're looking at the most likely arrival of tropical storm force wind. We have roughly a little after 9 a.m. on Wednesday for the Tampa Bay area. And then moving on to the Atlantic coast of Florida, that line that cuts through is closer to 9 p.m. on Wednesday. And we can look at this and we can say, some estimates. But actually HURREVAC is pulling in the underlying data that makes this graphic. And so you can interact with it a little more closely using our right-click tools. And this is also going to be the basis of the reports that we're going to look at pretty soon. So I'm going to zoom in a little bit closer and show you what if I wanted to label on this map an estimate of when that tropical storm force wind would arrive in an area between the lines, like here around Clearwater. I'll right-click. And the lower section of my right-click menu has the ability to turn on wind timing flags or labeling this data that corresponds to this graphic. So I'll click wind timing flags, place wind timing flags, and click into this sub-menu too. And so now I have a label where I right-clicked that says 12 p.m. Wednesday. So that's a few hours after what this black line is indicating. And I could continue to right click in as many places as I wanted to label this map. And as you might have guessed, if you were looking very closely at that right click menu, save wind timing flags as POIs is one way you can use points of interest to quickly retrieve information for custom locations. So if you're right clicking in these places, like I'm going to right click here around Fort Myers and place another flag there that says Wednesday at 10 a.m. And I'm going to come up here to the Panama City area and right click again and place wind timing flag that says 4 p.m. If I wanted to come back in a later shift or tomorrow and make this same graphic again that showed these labels along with this data without having to click, click, click over and over again, but quickly retrieve these, I could save my wind timing flags that I just placed as points of interest. And then the option below it at the bottom of that submenu called Load POI Wind Timing Flags, that would be all I would have to do to restore these flags in those areas that I just saved as POIs. And so if that's useful to you, know that that's a capability that exists. But because I haven't saved these flags yet, if I reload HURREVAC, those flags will go away. And I'm not going to be able to show these flags on the map unless I have turned on this layer, the Tropical Storm Force Wind Timing graphic. So keep this graphic and this sort of information in mind when we start to look at reports here in a little bit. Also, when we're placing these wind timing flags, it's not terribly important to have a lot of them in one particular town or one particular county, because this data density doesn't really allow you to see differences between one side of town or the other. The resolution is roughly on the order of a county. So it's better done and better understood on the regional scale like this, where you can sort of approximate and say late Wednesday morning along this stretch of the coastline between Fort Myers and Clearwater. And when I go to my other option in this graphic, the earliest reasonable arrival, these labels change. My wind flags are still there, but now they've got a light blue dot. And those have also updated to reflect those values for the earliest reasonable. And so I get a little more information about what's going on between these lines. So I have a readout that says 4 a.m. Wednesday near Fort Myers, and 6 a.m. Wednesday near Clearwater, and 7 a.m. Near Panama City. And to clear these off of the map, one way to remove the flags is to go down to the very bottom of the right-click menu, and you'll see that that's floating over the legend right now, is to remove wind timing flags. I can choose to remove the nearest one if I just want to undo my most recent one, or I can remove all flags to clear that off. And to keep things moving along, I'm also going to turn off this layer and go back to my track and swath options and turn my track labels back on. There's one more wind-related layer to look at right now, and that is the wind watches and warnings. And that is the icon that looks like a hurricane flag. And there's two options in here: wind watches and warnings, surge watches and warnings. And this is showing the depiction of the coastal watches and warnings. And this is, as I mentioned earlier, there's one exception to this color scheme in HURREVAC, and it's here. So here, this matches the color scheme you would see on the NHC website and those graphics. So blue represents tropical storm warning, red for hurricane warning, yellow for tropical storm watch, and pink for hurricane watch. And there are some areas like we see here near Mexico's Yucatan Peninsula where there is the pink hurricane watch nested outside of the blue tropical storm warning. They can coexist. And so we are tracking and plan to implement this season the new inland watches and warnings that are operational. And so if you're watching this as a recording, know that the interface could be different here pretty soon. And so you want to go to HURREVAC's announcements page or the user guide where we will let you know that the change has been made in the program. And so there will be a button, a way for you to turn on the inland watches and warnings that we saw in Robbie's presentation. And so you will have a solid color for those, except in the case of the coexisting tropical storm warning and hurricane watch, where there will be that blue and pink hatched fill in those areas. Now, this is one layer that can change on the intermediate advisory. We're here on 10A, moving up to advisory 11. You see that that changes. I'm going to go back in time a little bit to advisory 8 for the rest of my report demos, which we'll get to very shortly. And here's where we're going to ask, how often does HURREVAC get a new advisory that updates the wind forecast map layers? 4 options here: every hour, every 3 hours, every 6 hours, or every 24 hours. So how often will we see forecast map layers change with new information from the National Hurricane Center? All right, time to close this out and take a look at the results, and good job. Big majority saying that every 6 hours is the right answer here, and that is indeed the case. We get those main advisory issuances every 6 hours. Intermediate advisories can come at 3-hour intervals, but those are designed to update the position of the storm and update the watches and warnings. But the new track, the new probabilities, those are going to come at 6-hour intervals. And so you're never more than 6 hours away from the latest forecast in HURREVAC for an active storm that we're tracking. Poll question number 3. How far out can we get forecasts for tropical storm force wind timing? How far into the future can we look and get some information about when tropical storm force winds could reach us? Is it up to 3 days, up to 5 days, up to 7 days, or up to 10 days out? So what is the period of time that's covered by that tropical storm force wind timing forecast? Again, we'll give you about 45 seconds to a minute to get your responses in and then take a look. All right, and closing this poll question out, some interesting results. Let's take a look here. The most coming in with up to 5 days at 43%. Also some saying up to 7 days, 33%. The answer we're going for here is up to 5 days. So the graphical wind probabilities, the probabilistic layers, as well as the deterministic layers, both go 5 days out to tell us information about when tropical storm force winds could arrive. 7 days, that is the time limit that is covered by the tropical weather outlook. But we wouldn't be able to have any information in the program to tell you what's going on with the timing of winds 6 or 7 days in the future. So just to take another look at that here with this example of Milton Advisory 8, I'm going to turn off my wind watches and warnings and turn on my deterministic forecast swath. And see here we're at Monday, 5 a.m. is our advisory start time. And 5 days out into the future takes us to Saturday at 2 a.m. And with this graphic here, the most likely time of arrival, we're again starting here in this Monday time frame with the latest data going out past Friday evening into early Saturday morning, covering a 5-day period. So that is our horizon for having that information in the program on the map and also in reports. So if we're beyond that, we do have cases where we're tracking storms moving in from the east and they're still days away from the East Coast. And unless we are inside this graphic, this black outline, we're not going to have that probabilistic readout when we go to make a report. So I've mentioned it plenty of times now. Let's get into it. Let's start making some reports. We know our base location and the other areas I'm tracking are inside this graphic, so there's going to be some data for us to look at. So I'm just zooming back in so I know I'm clicking precisely here into Pinellas County, St. Petersburg. And the very fastest way to get a quick side-by-side understanding of probabilistic versus deterministic results for when tropical storm force wind could arrive is going to be this right-click report. Go to Create Wind Timing Report, which is fourth from the bottom. And you have two options in here. There's for selected point, which is just for the coordinates that I clicked in, or for locality, Pinellas, Florida. I'm going to show you an example of both, but to start out, I'm just going to talk about for a selected point. And what happens is the panel opens up from the right, and that has my results. And there's a black map marker on the map where I right-clicked. And so this is pulling in from that underlying timing data that we were interrogating earlier with the wind flags. And it's telling me for that point, as if I had placed a wind timing flag there, what is the earliest reasonable, what is the most likely. And it's also saving me a bunch of clicking because it tells me the deterministic time of arrival of the wind. Now there's a lot going on in this report on the right. I'm going to try to simplify this for you a little bit. I'm going to collapse the description in the top using that button. And you don't have to do this on your screen if you're following along, but I'm going to click Control+ just to zoom in and magnify this text on the screen here. And I'm also going to collapse this left panel. And so now we're just going to focus on this blue square. The top section of this report talks about the 39 mile per hour threshold. There is also another section that just focuses on the higher 58 mile per hour. But just for this demonstration today, we're focused on the 39 mile per hour winds. Why? The goal for HURREVAC here is that it's helping people make their protective actions take place before the tropical storm force winds occur, which are high enough to start causing damage and power outage and tree branches coming down. So ideally, those actions are taking place before that level of wind arrives. This tells us how much time we have through different frameworks, different types of data. So earliest reasonable, that is the most risk-averse planning assumption. And that is saying that 2 a.m. on October 9th, Wednesday, there's only a 10% chance that tropical storm force winds would arrive any earlier than that. And that is 45 hours in the future. That's what this right column means where it says 45. So 45 hours after 5 a.m. Monday, October 7th gives us 2 a.m. on October 9th. Most likely, that's the other version of the probabilistic forecast. Here we have 10 a.m. on October 9th as the readout there. That is 8 hours later. That's 53 hours past the advisory time. And it is normal to see some difference between the two, and also with deterministic. What does deterministic mean? Well, first I'll read this out, and then I'm going to go to the map to explain where this number is coming from. This is saying October 9th at noon, which is 55 hours in the future. So as I zoom back out, and collapse the report panel and look at this track and turn on this forecast wind field. What this is saying is that I move this 55 hours into the future. That is the time at which that estimated area of tropical storm force wind overtakes that point that I clicked in. And zooming in, you can see that that's the case. And if I proceed to move this deterministic forecast forward, it clears out of that point by 74, 75 hours into the future. This is just one scenario. This does not take uncertainty into account, but it's pretty straightforward to conceptualize. If this is all I'm looking at, I am missing part of the story though. Looking at this alongside my deterministic and probabilistic time of arrival kind of gives me an idea of what the range of possibilities are. What is going on with time of departure down at the lower part of this report readout? This second heading in the dark gray called time of departure, deterministic time of departure, we just saw that. That is moving that blue wind ring out of my point. That is 75 hours in the future at 8 a.m. on October 10th. So what I see here on my map and in my legend and in this report are all in agreement. Time of departure, as Robbie mentioned, is also something that's made by the NHC. It is brought into HURREVAC for emergency managers to use. While there's not a corresponding map layer, think about it like the earliest, reasonable, and most likely, just in reverse. So I'm going to turn off this wind field and reset to the 0 hour, just so that we're not confused at what we're looking at. Most likely time of departure is talking about when the tropical storm force winds are expected to move out of that point. In this case, that is 68 hours in the future, 1 a.m. on October 10th, is the most likely, the midpoint of all those different scenarios, that family of 1,000 scenarios. And then the more risk-averse planning assumption, there's only a 10% chance that these winds would be in that point later than 10 a.m. on Thursday, which is 77 hours in the future. So we just covered quite a bit of data there. Remember, if you're in a different time zone, you're seeing some different numbers that are tailored to the time zone your computer is in. But if you're wondering again, where does this come from? How does this come together? In the top right corner of this report is a question mark icon, and that, if you click on it, it opens the HURREVAC user guide in a new tab, and it opens on the page that is all about this particular wind timing report. So you can go into the particulars of what this means. Coming back to my other tab with my HURREVAC workspace, let's look at a few more examples of what's going on here. And let's talk about the county option. When I right-clicked there in Pinellas County, remember I said I had the create wind timing report. I could do it for the selected point for the coordinates or for the locality. If I do it for locality, I'd expect to see something similar, but maybe a little bit different, because now HURREVAC is pulling that data for the outline of this county, not just those coordinates. So I might see a slightly earlier time because a county is bigger than a point. So going back and forth between these two tabs, I'll collapse the description over there. It's actually pretty similar, except on the time of departure front, but you can have some big differences depending on your local geography. For example, if we come down here to Monroe County, if you're familiar with that part of South Florida, we've got the Keys, of course, which are spread out down here. Those are parts of Monroe County, but we also have this part on the mainland in the Everglades. And so just using my drawing tool here, that's about 116 miles from point to point in particular directions. And that can really make a difference in your results on this report, depending on which version you choose. So if I'm Key West in this situation, I'm going to get more specific information for my area if I choose the wind timing report for selected point. And of course, I have to be really careful where I click on these island geometries, because I might have just barely clicked into the water and not seen the option to make it for Monroe County. But if I right click here in Monroe County and do wind timing report for the entire county, now it's considering the entire boundary. And so that's why we asked that question earlier, what kind of area of responsibility do you have? If you're just one facility or campus or a small town, those coordinates might be good for you. If you're responsible for a county or parish, obviously, the right click by locality could be pretty useful too. And if you have a county that is very large or discontinuous, that's why you might see some different results. And speaking of seeing different results in here, zooming this back in, you might have times where you go and make this report and you will see something that looks like this. Going back to my slides. Earlier, I captured this morning when the first advisory was coming out for potential tropical cyclone 1. And for a portion of the Texas coast, I right-clicked and made this report, and I had my deterministic lines right here. And then for the most likely and earliest reasonable, it said TBD. Now, what was going on with that? Well, the data comes out at slightly different times. And so right as the advisory is coming out at the top of that hour, go back to my slides, that was the 10 a.m. Central Advisory. And I made this right at like 10:01, and this is what I saw. The probabilistic data had not yet gone on the servers and been loaded into HURREVAC. And so for the purpose of comparison, we want to make sure you are seeing the latest and greatest, and it's an apples to apples comparison with the latest advisory data. So it'll say TBD until all of that data has loaded in, and it's usually done so by about 5 to 10 minutes after the top of the hour that the advisory is labeled for. So if you ever see a TBD, that just means run this report again in about 5 minutes so that you're getting the latest because it is on the way. There's also going to be times, speaking about this wind swath, as I mentioned, down in the Key West area, notice that you're not, as of this advisory, in this deterministic wind swath. So if I made a report there, I wouldn't have deterministic timing data, but I am very much in the probabilistic forecast zone. So I would right click in here, create wind timing report for selected point, and I would get something that looks like this where I can show you earliest reasonable and most likely, but not deterministic. It says no data. And if you ever see that, go back and look at those map layers to understand what's going on. You know, if you're on the edge of that track, especially, this can be the case. You may also have times when you're at the very end of the 5-day forecast period. It's just started moving in. You're just starting to get in the cone, just starting to get in the zone where these products are touching that area you're concerned with. And you may also get some results where you would see the start time, but you don't see an end time. Because as I mentioned, the forecast only goes out 5 days into the future. So you might not have a time of departure until you're entirely within the 5-day period. As I continue to place more of these reports on the map, I could continue to make these new tabs populate in this report panel on the right side, a new tab for each location that I click into. I can close out of it. I could also be waiting for the new information to come out with the new advisory. Let's say I'm still in HURREVAC. It's 6 hours later. We're up to advisory 9. Clean up my map just a little bit. This tab is still showing me the results for advisory 8. But now let's say it is 8 a.m. I want to see what's new with advisory 9. I can click this update button, and that reruns this same report for that same point on the map with the new forecast data. And I see slight differences with all of these numbers here. Or if I wanted to, I could make a new report in a new tab just for advisory 9, keep the old tab open for advisory 8 so I can click and go back and forth between the two and see how it's trending. Is it getting faster? Is it getting slower? Do I have more time to make a decision? Do I have less time to make a decision? We're going to be using these variables a lot in Thursday's demonstration. So this is not the last time we're going to see it this week. That time of arrival, earliest reasonable, most likely, deterministic, that gets to how much time do you have to take protective action. And that's what HURREVAC is designed to pull together. So the fastest way to get all of this in one place is that right-click report for a county. But as I mentioned in that poll question we did at the very beginning, about half of you who are watching have an area of responsibility that's bigger than a county and bigger than a point. You're working on the regional level. Maybe you're working state or national watch desk, and you want to see timing information for a lot of different places all at once. How are we going to do that? Well, let's say I didn't even have this tab open yet. Let's just close out of that report, collapse that right side panel with that little arrow and kind of reset my view to what I had earlier. And bring my left side panel back out. Kind of reset the scene to where we were about 20 minutes ago. And now I want a readout of all the Florida counties' time of arrival of winds side by side. Which county is it going to potentially get to fastest? How do I do that? Well, I would go to the Reports tab. In my toolbox at lower left, it's the third option. I click on that, and that brings that side panel out. And then there's nothing showing yet. I have to click Create Report. And I have two options here that are good multi-location forecast. Here are those words again, probabilistic and deterministic. Let's say we start with probabilistic wind timing. And this takes a little while to load sometimes. The more counties that are in it, and also the more points of interest you have, it is trying to make a result for each one of those. And so if it's a storm that's affecting a lot of places, this might sit and think for some seconds before it pops up on the map. If it really does get caught up and you're just seeing a circle and it's spinning and it doesn't seem to be loading, what probably happened is while the report was being requested, there might have been a little hiccup in your connection to the server. It can especially happen if you're on a VPN or a unstable connection. The best thing to do is just try to create a report again in a new tab and see if that goes through. If it's really caught up, just reload HURREVAC, and hopefully that clears up what was just a transient internet connection issue. But anyways, let's interpret this. We also have some explanatory text at the top and a row for every single county or parish that is affected by at least a 5% chance of tropical storm force winds. Going back to this graphic right here. If it's inside this zone, there's a row for it in this report. So there's even the slight corner of Alabama, South Carolina, North Carolina, that has somewhere greater than a 5% chance, even though it's not the most likely scenario. But there is an ability to see the earliest and most likely time of arrival of winds in a comparison. Now, one of the shortcuts, one of the benefits of making a base location is that you can quickly filter out this larger list down to just your state or just find your county very quickly. So my base location earlier, I set that in Pinellas County, Florida. If I click this scope button and then click select base state, now it's only showing me the rows for the Florida counties. And notice that each one of these is like a blue hyperlink, and that means I can double click it for details. So if I want to investigate Charlotte County in particular and see that same kind of report we just did, where I'm also seeing the deterministic, I'm also seeing the time of departure data, I would just double click on Charlotte County and there's that report. It's a second way to get to the same kind of thing as if I had right clicked in Charlotte County. Let's close out of that and give you a demonstration of the other type of multi-location report. Go to create a report for deterministic wind timing. And the corresponding map layer for this, I'm taking off my time of arrival graphic and turning on my deterministic wind swath. So this report that we're now seeing on the map with these blue, yellow, and red headers, if a county or parish or point of interest is contained in this area, then there will be a row for it in this report. So in this report, there's only going to be a smaller number of Florida counties and a handful of Georgia counties in this list. But because I already changed my scope to Florida, I would have to change my scope back to all to include any of those Georgia counties in the results. What about those points of interest? Where did those go? How do I get to see those? That's going to be the include button at the top of this report. So by default, it's just showing you counties, but HURREVAC also takes anything that's in your list of points of interest. And if it's included in the area that has valid data, you can click and check this box on. So you're seeing both counties and points or just points by themselves. And now there's a comparison, a readout for those points of interest I made earlier in the demonstration: Cape Coral, Cedar Key, Clearwater. What time does the tropical storm force wind start in this deterministic forecast? When does it end? And that number in parentheses next to the time is number of hours into the future. And this is one way I can get some information about the timing of hurricane force winds if they're affected by it, with the knowledge that that hurricane forecast only goes out to 3 days in the future. The radii are not predicted out all the way to 5 days. But the tropical storm force wind goes out to 5 days. So not all of my points are a row in this result. Let's talk about that. Go back to my points of interest list in the map marker icon at the right, and I'm going to click the checkbox in the header to turn on my points. Remember, I made those points for Pensacola. I made the points for Key West too. They're not in this swath, so they are not showing up in this deterministic report. What about the probabilistic wind timing report? What does it look like here? Make sure I have my corresponding map layer. Pensacola just barely over the line, doesn't have that 5% chance of wind. So there isn't a row for it in this probabilistic wind timing report. But I do have results for Key West in this version of it. That chance of tropical storm force winds is actually 51% over the next 5 days, according to this column in the report. And again, I have that blue hyperlink look to it. So if I want to investigate in particular in Cape Coral at those coordinates I made, I'll close out of my window and show you. I get this same format of report we were just talking about with the side-by-side comparison of the time of arrival and the time of departure, except now it is customized to that point of interest I made. Final multi-location report we'll show you today is, let's jump forward in time to the end of this storm. Turning off my forecast track, and I'll turn off my points of interest, clear them off the map, and use my storm status bar at the top to fast forward to advisory 23. And this is the last advisory issued on Milton. Remember that other wind swath we were talking about, the past actual wind swath that kind of estimates the areas that were affected up to now? There's a corresponding report for this too. Create report, and I go to wind history. It's the last one in the list. And this looks a lot like the deterministic report we just got. Instead, this now is an estimate of when the winds started and ended in our various counties and points. Now, because in my last report, I had selected points of interest instead of counties, it remembered that preference. And so I just see the points in this list, but I can also check that box on for counties and see my points and my counties with side-by-side data. How do I get this information out of HURREVAC? I have two options. The only buttons I haven't talked about yet, and those are the export buttons. There's two in the top right corner. The one that just says export takes that report that's highlighted and opens a new tab in my browser, and it gives me a plain text readout that is very easy to copy and paste into another program. The other version is called export to Excel, and that saves an XLSX file into your download directory. That is another fast way to get this information out of HURREVAC and use it somewhere else, except that the formatting, the color formatting, doesn't come through. So be aware of that, but that gives you options for getting this information out of HURREVAC. So that covers our map players and our reports. I have one more poll question for you today. We've talked about two words quite a bit, deterministic and probabilistic. So which forecast product takes uncertainty into account and gives you more information about the range of possibilities? Does deterministic take uncertainty into account, or does probabilistic take uncertainty into account? So let us know what you think. Again, we'll keep this up for the next 45 seconds or so, and then take a look at what you said. By far, probabilistic is way out in the lead, 88% of you saying probabilistic, and that is the correct answer. The probabilistic forecast, we can see it in a number of different layers. It's that time of arrival graphic that has the most likely and the earliest reasonable options, and those same results in those reports. Deterministic is just that one scenario. It's assuming the forecast is going to play out the way it is spelled out, and it does not take uncertainty into account. So good job. And again, we covered a lot of ground today. It may be that you find, based on what your area is like and what your job is, that you gravitate to particular types of reports as you try to get this information out of HURREVAC. We're going to come back tomorrow with storm surge and inland flooding. We're going to talk about the rest of these storm tools that we have not gotten to yet. Now would also be a good time to bring Franny in and see if there's any questions or things we can demonstrate again.
Hey, John, one suggestion to show people how to turn something off instead of just on.
Yes, especially with these storm tools that have a little menu next to them. Instead of just clicking the button, we have to go down into this list again and click that row. So I've clicked on swath, and then I'm coming down to the past actual button that's highlighted. And when I click that again, that clears it off the map. Now, certain storm tools, and I'll close that menu too. Certain storm tools like the wind ring here, the forecast wind field, there's no menu in that. You just click it and it comes on and off as you click the button. Same with the error cone. Hope to see you again tomorrow and have a great rest of your day.